Welcome back. This is part 3, the final part of my Pascal live solve and solution explanation. I'm doing these problems for the very first time and explaining my own thought process as we go along. We left off last video at question 20, so this video will be on part C, questions 21 to 25. Now we're going to be moving on to part C. In this case, these questions are no longer multiple choice. They're asking for integers from 0 to 99. So let's keep that in mind while we're doing these questions. The answers are going to be either 1-digit or 2-digit non-negative integers. So let's jump straight in to question 21. We have a rectangle with positive integer side lengths. The perimeter is a multiple of 7 and the area is a multiple of 9. So what's the smallest possible perimeter of this rectangle? Okay, so let's draw a rectangle here and say it has side lengths a and b, where a and b are positive integers. We know that the perimeter is equal to 2 times a plus b, and the area is going to be ab. So what is the smallest possible perimeter of this? Well, we know that 7 divides p, so 7 divides 2 times a plus b. Since 2 and 7 are relatively prime, this means that 7 divides a plus b, and 9 divides ab. Now, looking at 9 divides ab, let's first look at 7 divides a plus b. This means that a plus b is a multiple of 7. So let's see what happens if a plus b is equal to 7. If a plus b is equal to 7, then the possible values are 1, 6, 2, 5, 3, 4, and the reverses of these three pairs. These ones have areas 6, 10, and 12. None of these are divisible by 9. So now let's try a plus b equals 14. If a plus b is equal to 14, notice that we can take ab to be equal to 9, 5, and the area is going to be 45, which is a multiple of 9. Thus, our answer is the perimeter, which is 2 times a plus b. Remember our factor of 2, don't put 14 as the answer. This is 2 times 14, which is 28. Okay. Moving on to question 22. A robot is programmed to complete these steps. Okay. So each step, the robot does the following. It starts at a certain point. It moves, say it's facing to the right. It moves 2 meters this way, turns 90 degrees to the left, and then moves 4 meters that way. And then, I actually need some more space, so I'm going to erase this and move down a bit. Say we start here. We go 2 meters in the direction we're facing and 4 meters after turning left. Notice that after this we don't actually turn. So what happens again is we're still facing this way. So we're going to do that again. 2 meters, 4 meters. Facing this way, so we'll do that again. 2 meters, 4 meters. And then we're facing this way, and then we do that again. 2 meters, 4 meters. And after 4 steps, we actually end up at the same place. This is explained because after you do this, you get a square of side length 6, and so it forms a complete loop. So the robot does this 26 times, but every time it does it 4 times, it's really ending up in the same place as the beginning. So this is the same as doing the process twice. So if we started here, we're going to end up at this point over here. Now, what we have to do is to figure out what this distance is. Luckily for us, we can use the Pythagorean theorem. This length over here is going to be 4 minus 2, which is 2. And this length over here is 4 plus 2, which is 6. So if the distance between the two is x, then we have x squared is equal to 4 plus 2 squared plus 4 minus 2 squared. This is 36 plus 4, which is 40. And that's our final answer. All right, for question 23, we have an octahedron. A number is written on each face. The number on each face is equal to the sum of the numbers on the faces that share an edge with that face. Wow, that's a lot of words. Unfolds the octahedron and erase the number on 5 of its faces, giving that net. Okay. How do we plan to approach this? Let me reproduce this net over here. Okay. Since this net is unfolded, it would be very helpful to kind of know which edges are connected to each other. So I'm going to use a different color for that. We can see that when we fold this area, these 4 triangles over here, they make a pyramid. So this edge and this edge are going to go together. Now, when we fold it again, this edge and this edge are going to go together. We fold that again. This edge and this edge go together. And now the interesting question is, this edge and this edge go together. So this means that these 2 edges on seemingly opposite sides actually end up together. Okay, so we have the numbers -20, x, 0, and -56. So let's see, what can we get from this? Well, notice that this triangle over here touches this one, and this one. This means that the one over here is going to be -20 plus -56 plus 0. So this one's going to be -76. Now, I think the easiest thing we can do is just to set up variables here. Let's call this A, call this B, and call this C. By looking at triangle C, we know that C is going to be, let me move this up. C is going to be equal to B minus 56. Looking at triangle B, we have that B is equal to A plus C plus X. Since we want to solve for X, let's isolate for X here. So X is going to be equal to B minus A plus C. Now, if we look at let's look at triangle, say the triangle with -56. Then since the 56 and the A are touching, we have that -56 is equal to A plus C plus -76. So A plus C is equal to 20. This means that x is actually equal to b minus 20. So we really just need to figure out what b is. Yes, okay, now looking at triangle A, we have that since A touches B, negative 20 and negative 56, we have that A is equal to B minus 20 minus 56, which is B minus 76. Okay, so now if we take this equation and substitute into this one, we get that B minus 56 plus B minus 76 is equal to 20. This gives that 2b is equal to 20 plus 56 plus 76. That's going to be, I believe, 152. 120, 132. Yes, 152. Dividing by 2, we get that b will be equal to 76. Right, let's see what happens when we fill in these numbers. We get that b is 76. This one's going to be 20. This one's going to be 0. And finally, x is going to be b minus 20, which is 56. So our answer here is 56. Okay, that one was pretty tough. But let's move on. We have a diagram with a lot of semicircles, and we want the area of this figure. Okay. So I'm going to draw this over here. 1, 2. On a 6 by 8 grid. 5, 2, 3, 4. Alright, and so we have points. I'm going to draw this in red just for some contrast. Points A, B, C, D, E. Oh, F is actually here. Interesting. G, H. Okay. We want the area of the figure bounded by all of these semicircles. So we have this semicircle, 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 and finally this semicircle. So we know how to handle circles and polygons separately. Handling them together is a bit of a challenge. So what we're going to do is we're going to break this up into circles and polygons. So let's draw in these lines. Alright. So we notice that kind of the area that we want consists of this polygon over here. We add 2 semicircles on the bottom and 2 semicircles on the top, and then we subtract 4 semicircles. So we notice that these 2 semicircles have a different radius than the rest, but all the other 6 semicircles have radius 1. Therefore, we can cancel out 2 of them. So cancel this, 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 and this. Alright, let's first figure out what the area of this polygon is. We can break it into these 3 trapezoids. This is 2, this is 2, this is 2, this is 2, this is 3, and this is 3. The area of this is going to be 2 plus 3 over 2 times 2 plus 2 times 3 plus 2 plus 3 over 2 times 2. That's going to be 5 plus 6 plus 5, which is 16. Now we need to subtract out these two semicircles. Know that they can combine to form one circle with radius 1. That's going to be pi. 16 minus pi. Now we still need to figure out what the radius of this semicircle is. In this one, this is A and this is B. And they're separated by 2 units to the right and 1 unit up. By the Pythagorean theorem, AB is going to be equal to the square root of 4 plus 1, which is root 5. So the radius is going to be half of that, which is root 5 over 2. When we combine these two semicircles, we get a big circle with area pi r squared. This radius squared is 5 over 4. So this is area 5 over 4 pi. Therefore, when we combine these, this gives an answer of 16 plus pi over 4. However, we still need to find the number closest to 100 times this. Let's pull out our calculator. Oh, this calculator does not have pi, but that's okay. 16 plus 3.14159 divided by, oh no, this calculator does things differently. Okay, let's do it the other way then. 3.1415926, that should be enough digits, divided by 4 plus 16 is, that gives this number, multiply by 100, so that's 100x, 1678.5354, and we want the closest integer to that. Since the fractional part is more than 0.5, we round up. So this 100x is going to be approximately, oh, I forgot what the number was. Let's recalculate that. It's going to be 1679. And when we sum the digits, we get 23. All right, now we have one more question. Problem 25. All right, let's take a look. For how many ordered triples of integers with, okay, so we have digits A, B, and C, and we want the sum of these three numbers to be divisible by 36. Okay. So, what we're going to do is we're going to look at, this is 7A, 6B, 5C, 2B, 9C, 5A, and 7C, 1A, 6B. First, we're going to split these into separate numbers. So we can split the first number into 7O6050 and AOBOC is 209050 and BOCOA 7O1060 COAOB. Alright, so let's add these three numbers first. So 0, 16, carry the 1, 16, carry the 1, 16. So 16, 16, 16, 0. Now we want the remainder when this is divided by 36, so let's do that. 36 goes 4 times into this is 144, 7, 17, 6, 4 times again, 144, 32, 321. So it goes 8 times into that. 4, 288. That's 33. 3 to 6 is 8 again, which leaves no, this is not 8, this is 9. Which 36 times 9 is 324, leaving 120. That's going to be 36, 3. So 12. Leaves a remainder of 12. That's what we care about. We can confirm this by just plugging this into our calculator. Yes, and we see that it leaves a fractional part of 1/3, which is 12 over 36. Therefore, we need that the sum of these three needs to be 24 mod 36. So how are we going to deal with the sum of these three? Well, what we can do is add them, and for a second, just ignore the carries. This is going to be a plus b plus c, 0. A plus b plus c, 0, and then one more a plus b plus c. We can factor out the number a plus b plus c. That times 10101. Now, 10101, this number needs to be 12 mod 36. Now we can use the Chinese remainder theorem to split this into 9 and 4. So this needs to be 3 mod 9 and 0 mod 4. Now, 10101 is divisible by 3. So this needs to be equal to 9k plus 3. If we divide by 3, this gives 3k plus 1. Now 10101 divided by 3 is 3367. So this is equivalent to saying that this is 1 mod 3. So I'm going to write that. Now 3367 is 3366 plus 1, so that's also 1 mod 3, so we can cancel that. So we get that a plus b plus c needs to be 1 mod 3. Similarly, a plus b plus c times 10101 needs to be divisible by 4. Since 10101 is odd, this means that 4 divides a plus b plus c, or a plus b plus c is 0 mod 4. Now, what we get is we can combine these to get that a plus b plus c is congruent to 4 mod 12, since that's a unique solution. Now, a, b, and c are integers between 0 and 9. This means that their sum is between 0 plus 0 plus 0. I'm going to call their sum s. 9 plus 9 plus 9. So the sum is between 0 and 27. The numbers that are 4 mod 12 are 4, 16, 28. Since 28 is too big, we only have these two cases. So now it remains to count the number of triples with a plus b plus c equals 4 or a plus b plus c equals 16. A plus b plus c equals 4. Well, I'm going to ignore the order first. And so the possibilities are Well, in this case, the condition that A, B, and C are less than or equal to 9 doesn't matter since they're all clearly less than or equal to 4, so we can use stars and bars. Since we have that they are non-negative, we can add 1 to each of them to get that A plus 1, B plus 1, and C plus 1 add to 7. And now they're positive, so we can use the normal stars and bars setup. We have 7. Those are 7 bars. I need 7 stars. We have 7 stars. And we need to split them into 3 groups, so we need 2 bars in 1, 2, 3, 4, 5, 6 spots. So there are 6 choose 2, which is equal to 15 solutions in this case. And then we have the A plus B plus C equals 16 case. Now the condition that A, B, and C are at most 9 matters. But first let's use the same setup as above. We had 4 plus 3 minus 1 choose 2. This is going to be 16 plus 3 minus 1 choose 2. Okay, maybe let's not do this, because that gives a really big number, and we don't want really big numbers. So we have 3 digits adding to 16. This seems very large. Let me first test if this actually works. If we have 8, 8, 0. I just want to make sure I didn't do anything wrong before doing this calculation. So I'm going to use my calculator. 7, 8, 6, 8, 5, 0 plus 2, 8, 9, 0, 5, 8 plus 7, 0, 1, 8, 6, 8. When we divide that by 36, oh, okay. I think I've done something. Because this does not give an integer, which is a problem. Okay, let's see where I went wrong. Oh, wait. I see. So what I did was, I calculated that the remainder of this number divided by 36 is 12. But I actually need this sum to be 24 mod 36. Now 24 mod 36 is going to be 6 mod 9 instead, so that's what I need to change. This needs to be 6 mod 9, so this becomes a 6, so this is actually 2 mod 3. If it's 2 mod 3 and 0 mod 4, this means that this is actually going to be 8 mod 12. Okay. This is 8 mod 12. Then, okay. If it's 8 mod 12, then the possible values are 8 and 20 instead of 4 and 16. So let's redo the calculation we were doing. A plus B plus C equals 8. Alright. In this case, we have that similarly to above, the condition with A less than or equal to 9 doesn't actually matter. So by stars and bars, there are 8 plus 3 minus 1 choose 2 is going to be equal to 10 choose 2, which is 45 solutions. And now we need to figure out A plus B plus C equals 20. If A plus B plus C is 20, how many possibilities are there? Well, what we can do is, since A, B, and C are between 0 less than or equal, well, that didn't mean for that to happen. A, B, and C are between 0 and 9 inclusive. This means that 10 minus A is going to be between 1 and 10. So if we substitute 10 minus A for each of A, B, and C, then we have that 10 minus A plus 10 minus B plus 10 minus C equals 10, where each of these is between 1 and 10. Since all of these are positive integers, this one doesn't actually matter. So now we can use direct stars and bars on this. This is 10 plus 3 minus 1. No, I don't need to add 3 because these are already positive integers. Okay, so this is just 10 minus 1, choose 2, which is 9, choose 2, which is equal to 9 times 8, 36. Alright, there we go. So we get 45 plus 36, which is equal to 81 solutions. Alright, that took a while. I almost messed up over here because I made a miscalculation over here when I calculated the remainder of this number to be 12, but forgot to kind of subtract it from 36 to get the proper remainder for A plus B plus C. So luckily I caught that, because otherwise there would be way too many solutions. It wouldn't fit in a 2-digit number. So it's important to realize maybe if you've done something wrong, something doesn't make sense, to kind of look back at your work from before, make sure that everything makes sense. But yeah, after that we can use stars and bars. Now make sure that you be careful between the 0 less than x and 1 less than x case on stars and bars. But other than that, we get the final answer of 81. And that's it for the 2025 Pascal contest. I hope you guys had fun following me doing all these problems. I hope you guys did well on these contests if you did them. And yeah, that's it for today. This concludes part C of my Pascal live solve. We managed to get through it without making any mistakes, but the final few problems were quite tricky. Be sure to subscribe so you don't miss out on any of our future videos, and we'll see you guys next time. Have a good one!